Right. So I've explained that the first thing that we do is to understand the output variable, right? Which this time around is the client depositing money in their accounts for a period of time. So I want to do a research on the meaning of term deposits, right? And Google has told us that term deposits is a type of account where money is locked up for a period of time. Because I've worked in the bank before, I don't even need to go further because I understand that banks have these deposit accounts where you lock your money. So you could go there and say you want to lock 1 million naira. The bank is going to use that 1 million naira to do whatever they're going to do, and they're going to give you interest at the end of the year, right? So I've explained that, right? Now, number two, the second thing you're going to do is that once you are going to study your input variables, you are going to need to create your own hypothesis, right? So you're going to need to create your own hypothesis. That's what you think. Obviously your hypothesis is going to be very wrong, right? But then you need to, like, while studying the data sets, create your own hypothesis, right? For age, this is an example now, right? I'm giving you an example. So for age, they are obviously going to be customers between the age of 18 and 60. I feel like usually in any climb, people between the age of 25 and 40, right? 25 and 40 are like the most financially buoyant people in any economy, right? So that's my hypothesis regarding age. Job type. For job type now, I feel like blue collar guys are rich. I don't know what the data set is going to tell me, but I feel like blue collar guys have some money. The guys in management have some money. So blue collar, they have money. The guys in management too, right? I feel like they will have some money. This is just my hypothesis. Retired guys too will have money because they used to collect gratuity. Abi? So retired guys will have some money. Services, I don't think so. Students, poor. Technicians, nonsense. Unemployed, no. Right? So that's my hypothesis regarding job. Marital status. How does marital status affect ability to deposit money? Divorced people, married people, single people, unknown, right? They said no, divorce means widowed or divorced. I feel like I really don't have an idea. I really don't have an idea what to say about marital status. So let me just leave it. Educational status, categorical. We have basic 4 years, 6 years, 9 years, high school, illiterate, professional course, university degree unknown. So of course, professional course people and university degree people will be very rich, right? So for education now, professional course. So this is for age. This is for job type, right? So you're going to study each of these input variables one by one. Obviously, it's going to take you time to do, right? You are going to need to take the pain to study each of the variables one by one, right? So these guys that did 4 years, 6 years, I highly doubt. There are some high school guys that make it, but they're like 1 in 1,000, right? So I highly doubt that they will have money to make deposits. But the guys that have university degrees, they will get good jobs now. The guys that have professional courses, obviously, these guys will have money, right? So I'm noting those down. Default, ask credits in default, categorical, no, yes, or none. Now, what's the meaning of this default? I'm throwing it to the two of you. So yeah, go and research, go to Google, go and research the meaning of this default, ask credit in default. What does it mean? This default variable. Does the client have credit in default? What does it mean? Go to Google and find out. What does it mean? Yeah, so both of you are correct. Both of you are correct. So this variable, this feature is saying, is this person owing? So you know, in these climes, like in the US, they have these credit facilities that their banks give them. So for example, if you open an account with a bank, your bank can decide to give you to put $1,000 in your credit card, right? And they expect you to spend that money and return it. If you spend $1,000 and you've not returned it, then you've defaulted. So you have credits in default. That's what this variable means, right? So this is a categorical variable. No, it means the person does not have is not has not defaulted. Yes, the person has defaulted. Unknown, we don't know. Right? So now, how does credit default affect being able to deposit? Obviously, an Onigbese cannot deposit money now because it's in minus. Right? So I'm going to write that down. So default. So for default, where's my mouse safe? So for default now, we are saying that if the answer is yes, then Okudiekato, we want to look at these people that are defaulting. They are going to affect ability of a customer to make term deposits, right? So let's go. Housing, does the person have housing loan? How does housing loan? Okay, don't let me waste time. Obviously, the person has housing loan. The person has some credit default, just like this, right? So yes, on housing loans is going to affect. Is obviously going to affect, or maybe not. We'll see when we analyze the data. But it's obviously going to affect their predisposition to be able to make a deposit. Now, person wey get money, they make deposits, right? It's a luxury. It's not something that people use to really make money. It's a luxury kind of thing. It's someone that has excess that will say, okay, let me go and keep 500 million in GTB, right? So housing loan, or let me just type it. So housing loan, yes. So if person has housing loan, we want to look at that, right? Let's go. Personal loan, obviously, this is another credit issue. So personal loan, say one of his friends borrowed him money and the person has been on his neck. If person has personal loan, we don't want to have anything to do with you, right? So they are telling us that this next set of variables are related with the last contact of the current campaign. Related with the last contact of the current campaign. What does this mean? Contact, month, day of week, duration, campaign, pay days, previous outcome. Numbers of contacts performed during this campaign and for this client. Numbers of days passed after this client was last. Okay. So what they are telling us that this from variable 8, the rest of these variables are related to. So these banks have campaigns, right? So they could call you and say, Alpha SA, we are offering you 15% interest rate on term deposits, right? So they've campaigned lots of customers. I think I've been involved in one campaign for FCMB once, right? So they campaign their customers to reach out to them to say, okay, we have this new deal that we think you can benefit from. So the next set of features are related to the last time this bank reached out to the customers in these data sets. Does that make sense? Okay, so before the meeting ended, I don't know where we got caught, but we talked about housing loan and personal loan, right? So I was explaining the meaning of this, right? That this line is explaining that the next set of variables are related to the last time this bank contacted the clients, right? So related with the last contact of the current campaign. Does that make sense? So for example, a bank contacted a client in January, right? Alpha, come and deposit money. They contacted them in March again, right? It could be the contact could be via email, it could be text, it could be direct call. Then they contacted them in September, right? Then they contacted them in December, right? So banks do campaigns, right? It could be an email campaign, it could be a text message campaign, it could be direct phone call, right? Alpha, now come and deposit money. Alpha, come and let's give you credit card, let's give you this, let's give you that, right? So that's what this data set is telling us, that it's related to the last contact of the current campaign. So for example, current contact type now is the contact communication type, right? Whether it's cellular or it's by telephone, right? This cellular just means landline. That the last time we contacted this client, how did we contact him? Was it via landline or was it via his phone? This one is saying, what was the last month of the year that we contacted this person? So the last contact month of the year. So January, February to December. This one is saying days of the week. What was the last day of the week that we contacted this person? Was it a Monday? Was it a Tuesday? Was it a Wednesday? So we want to see how all of these variables affect their decision making, so that we can decide that, okay, let's send out our contacts, our campaigns on Tuesdays. Oh, let's do it in March. Oh, let's not use telephone, let's use landline. Does it make sense?
So if I get you correctly, the one that relates to contact is more or less like, okay, when they finally decide to bring out info, so when they finally decide to bring out the output variable, they will know the best time to contact the person.
Exactly.
When they contacted person before and person responded.
Exactly. I mean, that's all that you gain from data analysis. It's as simple as that. It's not complicated. It's like 1 + 1, right? So contact, month of the week, day of the week, duration, campaign. I obviously cannot have an idea or any hypothesis to put forward for these ones. All right. So campaign is number of contacts performed during this campaign and for this client. That means how many times did we hit this person? How many times did our email enter this person's phone or a text message? How many times did we contact this person? P days says the number of days that passed by after the client was last contacted from a previous campaign. So how many days has passed since we last contacted this person? Previous says number of contacts performed before this campaign and for this client. So this previous is saying how many campaigns have we done that hit this particular customer. P outcome says the outcome of previous marketing campaign. Was it a failure? Was it non-existent? Was it a success? Companies need to see how all of these things play out, just so that they can use all of these things to make decisions. There are some times that, see, let me not lie to you, sometimes machine learning is not even important. I will not lie to you. Machine learning is not even important at all. Sometimes all a client needs is data analysis to be able to make decisions, right? So was employment variation rates, consumer price index. Is it part of this? It's not part. It's not part of the main. This is not part of the main data set, and I don't know why. So these are things that you want to look into. You want to call the guy in the bank and say, okay, these ones, why are they not part of the main data set? What happened? Is there a way we can join? Is there a way? Is there, excuse me, is there a place that where we can find them? Can we work on them? Can we see how they affect the output variable? Right. So these are things that we do. That we do in the EDA. So can you give me a summary of what you've learned so far? Let's see.
Okay, so I didn't get the last part, but basically said in exploratory data analysis display, we have 5 things: data collection, data cleaning, categorization and verify, enhancing outliers. I didn't get that part. Then you now said that on the first stage of data collection, after we got the data and recorded it as a CSV file, we have to do research to understand output variable, especially if it's not an industry that you do very well, but you need to understand what the client wants and why they want to, and the kind of, you need to understand what they want so that you can get the kind of insights that they are looking for. Then you now say we study the input variable and try to create our own hypothesis, that is our own opinion, even though it's not going to be correct. So we're looking at the input variable one by one after the other, and how they can affect output variable, like in this case now, how the marital status, personal loan, housing loan, if they've reported before, and then the last time they, how all of this can affect their storing money in a fixed account or locking it in a fixed account. They said something about listing variables. I didn't quite get that, but that's what I've gotten so far.
Okay, Layo, do you have anything to add?
Okay, basically, so you just mentioned that we should always spend time on understanding the data that we're given, that is understanding the relationship between the input variable and the output variable. So understanding that relationship can now help us draw an hypothesis that we can just put by the side. But it's always very important to understand, to explain and understand what each of them means, so we can now relate each of them to be able to get an output.
Okay, good. So while you were talking, I remembered something that I have not said, right? Which is very important as well. So what I'm about to say now is going to be important for feature engineering, right? So in machine learning or data science, whatever, we have input variables, right? And then we have the output variables. And we have one output variable. In the input variable, we can have as much as 100 input variables, right? So in the beginning, I told you that the first thing you do is you first study the output variable. Go to the industry. What does a term deposit mean? how does term deposit works? What's the interest rate? What do people, you can go to Twitter, go and check what people are saying about term deposits. Go to YouTube, watch videos, just basically do your research, make sure that you are very informed what the output variable looks like, and make sure that you understand why the bank or why the client so needs that output variable, right? And you do that most times by talking to a contact at the company, like, okay, why is this thing so important to you? Obviously, most times it's going to be so that the companies can make more money, obviously, right? But sometimes it's not every time that it could be so that they can make more money. Sometimes it could be so that they can retain customers. At the end of the day, everything boils down to more money, last. But it could be that so that they can retain customers. It could be that so that they can optimize their processes. It could be anything that is not related, that is related to money. But at the end of the day, last, you know that it's just so that they can make more money. So once you've studied the output variable, of course, I've told you that you need to go and study the input variable, right? But one thing I did not mention is that sometimes, or not sometimes, apart from studying the output variables, sometimes you need to study the input variables, how they affect each other. So how does this job variable affect marital status? How does marital status affect the education? What's the similarity between marital status and education, and how it affects their ability to make deposits? The reason is that if you understand and you can figure out insights from how these input variables affect each other, then you can decide to join two input variables to create a new input variable. Does that make sense? So that's what we call feature engineering.
Is it more or less that you are going to use this input variable to build one digital marketers like we call like an audience persona?
Yes. You see, what digital marketers call audience persona in machine learning is called clustering. I just intentionally not taught you clustering. So I've taught you regression. I've taught you all these are under supervised learning. So under supervised learning, we have regression, and then we have classification, right? That's under supervised learning. The third one is unsupervised learning, which is what? Clustering. What you people call audience persona is just basically clustering in machine learning, right? So it's just basically trying to gain insights from what customer groups can we separate from each other, and how are they different? It's just basically the same thing, right? So yeah, your question makes sense. So we could say, okay, how does these guys that are defaulting, how let's see, let's look at education. Are the guys in secondary school defaulting? Are the guys in professional certificate, do they default? We can look at marriage. Let's look at how marriage has affected our previous campaigns. It could show us that, okay, it looks like we've not really hit married people. No. It could be that married people are not opening our emails. No. It could be that married people are not getting text messages. No. Okay, let's go to housing. These guys that have housing loans, let's look at them. Is there a relationship between them and the duration of campaigns? This is how to get insights from data. So three things now, just so that you can remember. One, you study your output variable, right? Two, you study your input variables, right? And how they affect your output variable. Now, what I did not mention that I want to mention is that three, you need to study input variables. You need to study input variables and how they affect other input variables, right? This will help you to engineer features. You can create new features from one feature. This will help you when we get to feature engineering. Feature engineering. This customer could, you can engineer new features that they didn't even know that they had in their data sets. So this is what we call feature engineering. I want to write engineering here, whatever. Right? So there could be new features in these data sets that this customer this bank does not know that they had. There could be relationships between two input variables that they did not even have an idea that existed. That's the reason for exploratory data analysis, right? So I just wanted to mention this before. See, I can run through this code in 10 minutes, but you need to understand all of this. Data cleaning. So you know what we did in Excel, converting XLSX to CSV file. Is inside data collection, but it's a data cleaning process, sure? Because the data we downloaded was very unclean. And obviously, we know that real life data set is very, very unclean, right? So you need to, data cleaning is like some very important skill that you must have. So let me run through the data sets now that you understand this. So like I've told you, we'll run through one classification data set. Obviously, you can see that this is a classification problem because the output variable is in binary. So it's either yes or no. So it's either the person deposited or the person did not deposit, right? This second one we'll be looking at is a regression problem. We are predicting house prices for houses in this Indian city. This is a regression problem because we are predicting continuous variables, right? So we're going to look at how to analyze one classification problem and one regression problem. Then you go do your own analysis based on the template I've given you. There are lots of other things, though. I don't want to how do I put it now? I don't want you to think that this is everything that there is to data analysis. There are other things that you find online on YouTube, but I just put together a template that would help you get started with EDA, right? So obviously, number one is data collection, right? So we've collected our data sets from UCI. Our data set from UCI. We've done all of the pre-processing. And then we would obviously use read underscore CSV. There's something else called read underscore SLXS, XLSX. That's if you get your data set in this format, this is the original Excel format. So if you get your data set in this format and you want to analyze it in this format, I think this works. I don't know if I've used it once. I don't know if it still works, but you can, it's not only CSV, you can read data setting, right? But for today, we are doing read underscore CSV. So this is our data sets. Our data sets. Now I've put some text inside Colab. I said data sets which contain my oh, okay, good. So this is just basically giving you the reason why we do data set analysis. Sorry, EDA data analysis is that, for example, this obviously from this data set you can see that this data set is divided into two, right? The first half of the data set is the characteristic or the properties of the customers. Obviously, you can see the job, marital status, balance, housing, loan, right? The first half of the data set is talking about the properties of the customers. The second half of the data set is talking about the previous campaigns and how the previous campaigns have affected the outcome of this data set, which is the deposits. So we are looking at how their properties have affected deposits. We are looking at how our previous campaigns have affected deposits, right? So this is just for this particular data set. And then the second thing is that we're finding out customer segments using data for customers who subscribe to term deposits. That's so, why is it echoing? Okay. So so the next thing is data cleaning. In data cleaning, I put some text here that I would love to use, that I would love to read to you. So these are a couple of things that you can use to fix rows. I like this data set because it's very, very dirty. You can see 000. You can see none. So most times when you do DF or when you open your data frame, you'll find out that so many things are wrong with your data frame. So there are a couple of things you can do. I think I've sent this particular collab notebook to you. You can do to fix your rows and columns. One thing, number one, is that you can delete summary rows and columns. This is what you call summary rows and columns. So for example, you have something like this, ID. You really don't need this ID. So you can delete this particular row. There are some columns that are just summary of some particular properties, right? So you can delete summary rows and columns. Delete extra rows with blank rows and page numbers, right? So just basically cross-check, go through all your rows and columns, do a physical cross-check and find out what rows and columns you don't need and delete them. We can merge different columns. We can merge different columns for better understanding. I think we can do that much later under feature engineering. We can split one column into multiple columns based on understanding. This also is a feature engineering issue. And then we can rename columns, right? So you can change. So once you understand what this column does, you can rename the column. So remind me when we get to this house pricing, I didn't put column renaming there, but you can. Okay, so I'm going to even give you a project, right? So you go to Google and type how do you rename columns in pandas and rename all these columns. But that's when we get into regression, right? So those are a couple of things that you can do while once you've read your data sets. So data cleaning, obviously, the most important thing in data cleaning is deleting null values. Null values, so there are no null values here in this particular data set, but there are null values here. So I can use this. So this, when you see something like this, NaN is a null value. It means that this is a missing value, and you need to work with missing values. There's couple of things you can do with missing values, right? There are a couple of things you can do with missing values in data sets. You can actually delete them. You can actually delete them. So for example, I mean, all of these things are just based on experience and understanding. So let's say you have this feature, this particular project has how many rows? So you can see this project has 11,000 rows and 17 features. That's 17 columns, right? So let's say a particular row now. So 11,000 rows, right? And a particular row has 9,000 missing values. What are you supposed to do to that row? Liar. Liar. Okay, good. I said a particular row. Let's say that row is let's say duration row, for example. This data set has 11,000 rows, right? 11,000 rows. But this duration has 9,000 missing values. So we have 11,000 rows in the data set, but yes, it has 9,000 missing values. So what do you do to it? What do you do?
My network is really breaking, but let me get what you say. You're asking if the default colon has 9,000 missing values.
Yes. Yes.
Right?
Yes.
So I think we will remove it since it's like almost all the values are like null. So we can.
Because this is a standalone project. I said you're correct. Because this is a standalone project, right? What you're going to do is to remove it. But in real life, what you do is to call the bank or call your client or call your data engineer and find out why you have so many missing values. Like, I always want to put you in a business mindset once you are learning, right? Because you are learning to be in a business environment. So what you do is that you call your data engineer, or you call the cloud experts, or wherever the data is coming from, that why do we have so many missing values in this row? Is there anything we can do about it? Once you find out that there's nothing you can do about it, then you remove it, right? So that's that. So everything is just based on understanding, right? So this is the code. This is the code to.
I want to ask you a question.
Okay.
What if you assign like values to those missing values? Like, how does it work now? So when you are using SSPSS, you are able to assign like a way so that when I don't know if you understand.
I understand what you are saying. So let's say, for example, a particular row has 500 missing values, right? You cannot delete, and let's say during your analysis, you find out that that particular row is very important to your target variable. It doesn't make sense to delete it now. So what do you do? That's your question, right? There are certain things you can do. You can replace that missing values with the mean of that row. You can replace it with the standard deviation, right? You can replace it with the median. You can replace it with the mode. You know what mode is? Right? Okay, so remind me, once we go to the next class, remind me to show you how to replace missing values. So you can replace values with mean. You can take the mean of that row and replace those missing values with the mean. You can replace it with the standard deviation. You can replace it with the median. That's the average. Okay, sorry, what's median again, sir? That's the middle, right? And then you can replace it with the, yeah. You can replace it with the mode. That's the most frequently occurring numbers. You can change the missing values to all zeros. So these are 5 things you can do with missing values. It just depends on the business context and whatever the business guys tell you about that particular role. Whatever they tell you about that role would let you know which one you should do or which one you are comfortable doing. If the missing values are not too much, let's say the missing values are 15 out of 11,000, you can change out those missing values to 0. If that feature is not too important, right? You can change the missing value to 0. It will not affect your work. But the feature is very important. So, for example, let me show you something. At the end of this notebook, we use machine learning to find out our most important. We use machine learning to find out our most important. What do you call it? Why I open my cell now? Why are you hiding it? So we use, no, not here. Let me show you something. So we did something called feature importance using a machine learning model called XGBoost. So for example, the most important feature for this project is contact, right? The most important feature is contact, right? If under contacts we have 20 missing values, since it's our most important feature, I could decide that I want to change these values to mean. But if the feature is not that important, what's the least important now? P outcome is the least important, right? If P outcome has 500 missing values, because it's not very important to me, right? It has 500 missing values. Because it's not very important to me, I can decide to change the missing values to 0. Does it make sense? I mean, the decision has ended.
Okay, so what I'm trying to say is that So is there a way you can check pictures that I think you've been able to show us the graph? So is there a way you can check pictures that are important and not important?
Yes, now that what I just showed you is in the notebook, right? But I did not start with this first because you really do not need this. This is just like you've done. It's just like you've done your homework with all of the things that have come before, right? This is just like a validation to the insights that you've gained in this project, right? I don't want you to rely on feature importance because it's not really that important. Sometimes XGBoost might not really give you, might give you, and might tell you that a feature is important when it's not really important, right? So I don't want you to rely on feature importance library, but it's like a validation to all of the insights that you've gained while doing the things that you've done ahead. You understand? But yeah, it depends on the importance of that feature to the project that you're carrying out. That's what will decide what you should do to missing values. You don't just treat missing values anyhow, right? But everything depends on context. Does that make sense? Does that make sense? Okay, good.
So that means from the research, that was that one.
I'm listening. Go on.
Okay, so that means from the research that we must have done, from the input variables and the output variables, it might give us an insight to know whether a feature will be important or not.
Yes.
In case we have a lot of numbers.
Yeah, yep. That's correct. So let's go back. So this is the code to find out which data set is clean or not. There are more than 5 different ways of checking out data cleaning in Python, and you'll find a lot of them online. So as I've told you, the code is not very important for me, right? If you Google missing values in pandas, knowing how to use Google is another very important part of data science, because you are never going to be a perfect coder. You always need to find out, okay, how do I write this code? So you always find different ways to do different. You can write one code, you can write 5 codes to do the same things in Python. So for me, the syntax is not all that important. People just overhype it. I don't think it's that important. The most important thing is the business understanding, right? So this code has told me that for this data set, we don't have any null value. Unlike this one, see this data set, after doing data cleaning, look at this guy had 1,453 null values out of, okay, so look at this. We had 1,460 rows, right? Out of 1,460 rows, this particular row has 1,453 null values. Obviously, I'm going to drop this data set. There's nothing you can tell me. All these ones that had 99% to 17%, I'm obviously going to drop all of them. I mean, you cannot even negotiate it with me, right? So that's about data cleaning. So let me just run through the code.
So I want to ask a question.
Okay, go on.
What's now the difference between data cleaning and feature engineering?
At the end of the day, there's no difference. They are basically doing the same thing. But data cleaning helps you to so let's look at this. There's actually no difference from my experience between data cleaning and handling outliers. Handling outliers is just a form of data cleaning, because outliers will affect your machine learning projects. right? But outliers will also help you to understand the data set better. That's why I separated it from data cleaning, right? So for example, in a particular row, we have 1, 2, 3, 4, 5. And then all of a sudden we have 1,000. And all of a sudden we have 1,500. Obviously, this is an outlier. But it's not every time you drop outliers, because outliers are an insight on their own. So you need to understand how to handle outliers. That's why I separated handling outliers from data cleaning. Outliers removal can be a form of data cleaning. In fact, it's a form of data cleaning. But outlier itself is insights, right? You could help this bank understand why these particular guys are doing what they are doing. You can tell the bank to target these guys that are doing 1,000 and 1,500, and to help the bank make more money than these guys that are doing 1, 2, 3, 4, 5. So that's the reason why I separated outlier from data cleaning. Handling outliers is a form of data cleaning. Just the same way data cleaning and data engineering are not too different from, and feature engineering are not too different from each other. Does that make sense? So we've done data cleaning. There's more to data cleaning though, but we'll look at more later. I don't want to disturb you with a lot of information. So the next thing is that categorical and numerical variable exploration. Again, obviously, if you look at this data set, you know that some data sets some features are categorical. For example, marital status is a categorical feature. So it's either the client is married or unmarried. Default is either yes or no. Educational too is categorical as well, although there are 6 classes in educational, but it's also categorical. Balance is numerical. Day is numerical. Duration is numerical. Very good. Very good. There's a problem in this data set that I want you to see. I want you to show me right now. Look at this data set. There's a problem. Just merely looking at this, there's a problem with this data set. I want you to show me. Good. Good. Right? This minus does not, you should not be having minus in your machine learning project or your data analysis project. So what you want to do is you want to call the client and ask why this minus. Is it a mistake? It could be a mistake from the data source. Right? So all you do is you go and remove this minus and change it to, and it will become a whole number again. So yeah, that's for that. So data cleaning, we would look at categorical variables, right? And we'll look at the numeric variables. Let's explore. So let me run through this code. So this is the code to check for categorical variables. So don't forget, we've already done DF. We've already done DF is equals to PD underscore read CSV. So every other thing that we'll be doing for the rest of this code will be carrying DF, right? So if you remember when we did the run to Python, we did assignments, right? So this is a variable, right? We've assigned this property into this variable. So for the rest of this data set, we'll be using DF operations, right? So DF, if you do df.select underscore d type, include equals to object, it will bring out all the categorical columns for you, right? So these are the categorical columns. We have job, marital, education, down to deposits, right? So now let's look at categorical columns, right? So this is just a code to show you the distribution. If you remember in our last class exactly, we talked about normal equation. If you go back to the last class, we talked about normal equation. What I didn't explain to you in that class is that most time in data science or in machine learning or whatever, it's very okay for your data set to be a normal equation. This is what normal equation means. When your data set distribution looks like this, is a normal equation, right? The data set distribution looks like this. It doesn't have to be perfect, but if it looks like this, like office maybe by sorry, let me speak Yoruba. Like I don't know how to explain it. For unlike when your data set looks like this is not a normal equation, it's not balanced, right? So this code is just to explore our data set to see if our data set is a normal equation. This job is not a normal equation, but it looks just okay, right? Marital is just okay. Education is just okay. Default is not okay, but I mean, it's just okay at the same time. It means that we have a lot of people not defaulting than defaulting. This is just okay, right? This is just okay. All of these are not bad. We don't have outliers in this categorical features. There are no significant outliers. This just looks good, right? This looks not bad. This is just okay. All of these are just okay to me. Maybe this is too much, but it's not too far, right? So this is just okay, right? So we've explored categorical features to see that there are no serious outliers in categorical variables. Now let's go to our numeric variables. We could have used this same code to find out numeric variables, but I researched another way to do it, right? So we can do df.columns and pass it into this calls variable and say df.get numeric data.column. So this is going to get all our numeric data for us, right? So we have age, balance date, duration. That we'll use the same code that we used for categorical variables, right? I use the same code. I just changed the variables, right? So let's look at let's explore our numerical variables now. Let's explore them. What can you see? What do you notice in these numerical variables? What can you notice from this?
The distance between some, like the distance is too much for some of them.
Okay. What else?
And they have almost the same kind of distribution.
It's only days that has almost the same type of distribution. So this day distribution looks like it looks like it's perfect, right? Since how many days do we have? We have 7 days, and so we have so this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, but it's more than 7. So I want to find out why we have more than 7 days here, but then it looks perfectly okay. This balance doesn't look perfectly okay to me, right? I want to find out why. Or it could just mean that we would need to delete the guys in this place, right? So it means that these guys are the outliers here. These guys here. I need just to delete them, and then this is okay. Duration looks fairly okay to me. Just like okay, why is this bar so far from this bar? But for me, it looks like this duration is not so bad. What is bad at this 3? Too bad. Too bad. So we know we have outliers in campaign PD. So let's go back to our jottings, right? So from here, we decided that this was my hypothesis. For age, I was interested in people between the age of 25 to 40, right? For job, I was interested in these guys in management, retired, and I've forgotten what this is. For education, I was interested in guys with professional degrees and the guys with BSc or something, the guys that went to uni, right? And then for the defaulters, I was interested in the guys that default, the guys that have housing loans, and the guys that have personal loans. This was my personal hypothesis. But now I'm gaining new insights into this data, right? It could be a problem, and at the end, it could not be a problem. Some problems could turn out to be insights, right? My voice is echoing again. So what am I seeing now? I have a problem with campaign, I have a problem with PDs, and I have a problem with previous. So I have a problem with campaign. Okay, let me type it instead of. I have a problem with campaign. I have a problem with PDs, and I have a problem with previous. Let me title it problem. So all these things that I'm showing that we are going through, it could be that we might have to drop the columns, or sorry, the rows because of this problem. And it could not be that it could be that this is showing us new insights, right? So then, because of the fact that these three columns have problems that we can obviously see from this visualization, we now want to look into the data set closely. We can use df.describe. .describe feature in Python gives us statistical analysis of the feature. So for example, I could decide to do a .describe for all of my features, right? I can do that under this. I can do that under this. So let me create a new code under this, right? I can do df.describe. Has the data set disappeared again? So I don't know why it's always disappearing. It has disappeared again. Sorry, hold on. Where are you? Okay, what did this say? I think you already won yourself. So okay. I want to show you what the describe basically does. And I remember that I've mentioned this to you before. Right, so you do df, should run our code now. Right? Now if you do df.describe, it should give you statistical analysis. I don't like it this way. I don't like it this way. I don't like it this way. Okay, good. Count obviously just means that this is the number of rows. Okay? That's the count. Count is another thing you can use to know if there are missing values. So you look at all the counts and measure that the count is the same thing, right? The mean, obviously, you know what mean is. I don't need to go into statistics. Mean is just the average value in this row. So let's look at age, for example. STD is standard deviation. Mean, this is the minimum value in this row. This is the maximum. This is the 25% percentile range. This is the 50% percentile range. Do I need to take you a class on statistics?
Yes.
Okay, your solar will do that. I remember your solar is on me in statistics class. So your solar, the statistics graduate guy, I think you will do that maybe during this week. But I just want to show you how to know if something.
But you know the one that was going to take us a class earlier.
Yes. I'm the one that has not disturbed him. So I want to give you 3-4 things to know if something is wrong with your data sets, right? And you might need to write them down using df.describe. The first thing is the count, right? So let's look at, no, so now we have problem with campaign PDs and previous. Now we now did df describe on these 3 rows. The first thing is you look at the count. I think I should have even written this down in the collab notebook so that you can remember. So the first thing is you look at the counts. You look at the counts. What's this one? So you look at the counts. The count is balanced. So let me go back to my original code.
Actually, how do they the count is balanced?
Yes, because this counts 11,162 is the number of rows now. If you scroll up, you remember when we did DF? DF told us that when we did DF, what did DF tell us? That there was 4,000. Wait, something is wrong. DF told us that there are 4,521 rows, right? Okay, something is wrong. Something is very wrong. Okay, good. So DF says 4,521 rows, right? Just to show that the number of rows is intact. So DF told us that how many rows? 4,521. That's the count, right? That's the very first thing. So the first thing you want to make sure that there's no missing values and that this count is intact, right? So everywhere here we have 4,521. So we are good to go. The second thing I want you to look at in df.describe is the mean and the standard deviation. Second thing is the mean. Let me type, Jerry. So the first thing is the count, right? Make sure that is steady. The second thing is the mean and the standard deviation. Very important. The standard deviation was named very well, right? Standard deviation was so named perfectly, right? The standard deviation just means that what is the deviation from the mean, right? So if the mean of a row is 10 and the standard deviation from the mean is 1, then it's still okay. But if the mean of a row is 10 and the standard deviation from the mean is 100, then there's a big problem. The standard deviation must not be more than the mean. If our standard deviation must not be equal to the mean, standard deviation must be very tiny compared to the mean. That's what I want you to look at a mean and standard deviation. So, and I remember I mentioned this to you before. So let's look at P days. Our mean is 39. Our standard deviation is 100. Can you see that this is a big problem? Campaign, our mean is 2.7. Standard deviation is 3.1. Very big problem. Previous, our mean is 0.5. Our standard deviation is 1.6. That's obviously why this data set is like this. Obviously why this data set is like this. Let me go and check days now. Let me go and involve days here. What happened now? Oh, D. Sorry. Look at D. The mean is 15. Standard deviation is what? 8. That's why D was balanced. That's why D looks balanced. So I could obviously tell that I would not have a problem with mean and standard deviation from what I could see here. I'm very sure this. Okay, so let me go and add balance to it, just so that you can understand. Let me go and add balance feature. Look at balance. Balance, the mean is 1,422. Standard deviation is what? 3,009. This is a big problem. So that's number 2, right? Remember I told you that our goal is to have a normal equation. These are the reasons why you are not going to have a normal equation, right? The first thing is if the count is not steady. Second thing is that if the standard deviation is more than the mean, then you're not going to have a balanced data set, and you're going to have very serious problems, right? So that's number 2. The third thing I want you to notice in df.describe is that the mean and the 50% percentile must be the same thing. Since mean means average, right? Since mean means average, the mean and the 50% percentile must be equal. If it's not equal, it must be close to it. So let me go and write that down now. Number 3. The mean and 50% percentile. So these are things that show that just basically shows us that something is very wrong with our data set. So the mean here is what? 39. 50% percentile is -1. So very serious problems. Mean here is 2.7. 50% percentile is 2, which is not bad. Mean here is what? 15. 50% percentile is what? 16, which is not bad for this particular feature. The mean here is 0.5. 50% percentile is 0, which is very bad. Mean here is 1,422. 50% is 444. Right? So very serious problems. Imbalanced data sets. This is not a normal equation. That's why obviously we have things like this. Usually we should have something like this. If it's not like this, it should go in this direction. It should go in this direction, right? The last thing that I want you to. Okay, go on.
So if the line was breaking, you said that the mean and 50% percentile, they must be close, right?
Yes, they must be the same thing or they must be very close. Like this 2.7 and 2. I would have loved it was closer, but it's still not bad. Look at this one. The mean is 15.
Okay.
And this 50% is 16. No, it's not bad.
Okay, so I have a question.
Okay.
This data set now, what if you gave us 3 conditions, and the second one was the standard deviation was not more than the mean, or was not be equal to
yes,
the
yes.
The mean and 50% was equal or close.
Yes.
What if a particular row, like the one we are looking at now, what if previously meet second condition but does not meet the third condition? Is there anything going to happen? Must they meet both conditions?
Yes, now they must meet all conditions, though. They must meet all the conditions here. Yes, ma'am. Before you say that you want to go and fit or you want to go and carry out data machine learning, which is the last thing we are going to do. Before you say you want to fit this data set on any machine learning model at all, This data set must pass through these conditions and it must fit all the conditions. Is that gotten?
Okay, so that means anyone that we need to hide because before
she said she asked the question. She said, does one of these conditions need to be satisfied or everything needs to be satisfied? And my answer is that everything needs to be satisfied. Did you get that? Good. Number 4 is that 0%, 25%, 50%, 75%, and 100% percentile. How do I frame this now? They must what's the word to use now? They must make sense. Like, you know your data, you know when your data set is you know your data set is a normal equation when, for example, this looks like a perfect data set. This day looks like a good data set. Minimum is 1, which is 0%. 25% is 9. 50% is 16. 75% is 21. And 30% is 31. It looks like a balanced data set to me. Unlike, look at campaign, you have 1, 0%. 25% is 1. 50% is 2. 75% is 3. Maximum is now 50. I wish I had words to be able to explain what I'm saying now or be able to frame it better, but does it make sense to you? Look at previous. 0% is 0, 0, 0, 0. All of a sudden, you have 25 here. Or look at balance. Your minimum is minus 3,000. So you can see that all of these rows need to be subject to data cleaning. All of these rows, they need to be subject to data cleaning, right? That's number 4. Oh, good. Okay, guys, I'm going to, can you guys hear me? Hello?
Yeah, yeah, I can hear you.
All right, guys. So I'm going to rush through the rest of this class, so that I can I wish we had more time. But what I will just do is that before the next class, I'll make sure your student takes you through statistics, because I feel like statistical analysis is another thing that you need to understand the rudiments of, for this to make sense. So I don't want to rush. I don't want to rush this knowledge. I want you to take it little by little before we get into. So the next thing we'll do after this is feature selection and feature engineering. But we're already inside, because these things are intertwined and interwoven. We're already inside the insights that will make you decide, okay, which feature should we select, or which feature should we create out of which feature. All of this EDA we are doing is what will help you determine what to do in feature selection and feature engineering. That shouldn't take a lot of time, and then we'll go into machine learning, and then after that, I want you to go to Kaggle and start solving business problems. So I mean, we'll do that together anyways, but then I want you to go through this entire process. So I want to rush through the rest of this class, right? So obviously,
Before you continue, you were saying 0%, 25%, 75 and 100% percentile was that last condition.
I don't know, I don't have an adjective to use to explain this now, but the must let's say they must be close to each other. Is that a way to frame it? Right? Let's say they must be close, right? So for example, I already explained, look at this day variable. The 0% is 1, 25% is 25, is 9, 50% is 11, 75% is 21, and maximum is 31. This looks like a balanced data set for me based on this condition. Unlike when you have 1, 9, 16, 21, and your maximum is 1000. Look at previous. Minimum is 0, 25 0, 50 0, 75 0, maximum is 25. So from 0% to 100%, it must flow. Is this particular day data set that would give you a feature that looks like in a normal equation, right? So that's what I mean by 0%, 25%, 50, 75, and 100% percentile. It must flow, it must be close to each other, such that you can see that there are no serious outliers here. Unlike, look at this now. Look at balance. 0% is the minimum, which is minus 3,000. Let's even forget the minus 3,000. Let's look at the flow. 25% is 69. 50% is 50, is 444. 75% is 1,480. Maximum is now what? 71,000. This is too far from 75%. Do you understand what I'm saying? Maximum is too far from 75%. So it's not a normal equation. And then the last condition, which is not far from this, is that you look at 0%, you look at 0% percentile, 0% and 100%, right? Which is not too far from this, right? So these 5 conditions, let me see if there is something else I've not mentioned. I don't think so. Right, so this must flow, and then you look at your minimum and maximum. Minimum and maximum. Minimum is 1, maximum is 31. right? Minimum is 0, maximum is 25, problem. Minimum is minus 331, maximum is 71,000. So the long and short of what we've done in df.describe just tells us that these rows or these columns, sorry, these rows have serious outliers and they are very imbalanced, right? So that's the reason for numerical and categorical variable exploration. It's an exploration. We are not getting insights from it yet. It's just an exploration, right? So that's number 3. I'll rush through this, right? So this code, if you go back to introduction to Python, have you guys run that the 2 codes? Have you run it? Did you run the intro to Python code? If you did, you would have seen learn. If you did, you would have seen this learn function in introduction to Python, right? So what we just want to do here is that looking at P days, for example, P days, where's P days? P days, you can see that we have outliers. But okay, let me see. What's the number of what's the number of rows in P days that is more than 400 and multiply it by 1,000? So we find out that we have 1.2% data set that is more than 400, right? You can use anything. I just use 400, right? So data set is telling us that minimum is -1, maximum is 841. So minimum is -1, maximum is 871. I'm just doing a manual check to say, let me see how many data sets how many percentage of this data set is over 400, right? And we found out that 1.2% of this data set, 1.2% of this data set is more than 400, is over 400. What does this tell you? That's why I wanted you to run this code with me so that we can analyze. I don't want to teach you, right? I want you to analyze it yourself as I'm speaking. Now, we have data sets between -1 and 871, and only 1.2% of this data set is greater than 400. What does this tell you?
That means there's so much gap between the max SF1 and then the other one. Because, wait, sorry, 1.2%, sorry, right?
Yes,
it's greater than 400.
yes. That means, let me distill it. You said what?
If 1.2% of the whole data set is greater than 400, so that means it's actually close to 871.
I don't agree with you. Let me distill it to you. Let me distill it. It means that if you have 1,000 data sets, right? Only 12 data sets out of this 1,000 are greater than 400. That's what it means. That if you have 1,000 data sets, so only 12 data sets are greater than 400. What does this mean? What does this? Exactly. So what are you supposed to do to this row?
So we can either remove or we can now replace. Wait, sorry, can we call the other number?
No, there are no null values now. There's no null value in this data.
So that means it's not so much, it's not going to be really big for us.
So what do we do? Let's say, what do we do to this row? What do you do about this row? We should remove it, Abby, since it's not plenty. So that's why I ran this code. right? Since I know that now there's a problem, right? So let me see how many data sets in this row are more than 400. So we have 1.2%. So we might need to drop, sorry, I said drop this colon, no? We might need to drop the rows, the colon, right? I'm correct. So we might need to drop this 1.2%, right? So let's look at campaign. Campaign, we have minimum is 1, maximum is 50. So I said, let's look at percentage of campaign values that are above 20. And here we have 0.03%, right? Obviously, you already know what to do. So numbers of campaign are clearly noise. So I suggest to impute them with average count. I mean, what I'm teaching you is that what I wrote in this collab notebook is not exactly what you have to do. It might mean in a different project, you might not have to drop these columns. You might have to go back and study why it is the way it is. That's why exploratory data analysis takes time and is a lot of pain to do. Right? So you might not, you necessarily don't have to drop it, but you need to study why it is like that before you drop it. Right? So that I don't give you I don't deceive you to think that every time you see outliers, just start dropping. No, it's not every time you just start dropping. Right?
I think I'm noticing something. In your code, you put greater than 24 instead of greater than 20.
Oh, okay. So that's a problem. Thank you. Right? So that's a problem inside my campaign above 34. That's where my commenting. Right? So this is 34 as well. Right? So let's do so for values too. So we go to the previous column and say, okay, previous, this one is even very bad because minimum is 0 and maximum is 25. So for values, we said, let's check for where is value? For previous. Abby, was it previous? Yes, let's check for previous. That's why I made a mistake. For previous, I want to check the colons above 20. So we have 0.08%. Let me check values above 21. What about values above 22? What about values above 23? What about values above 24?
It keeps decreasing as you are increasing the value.
So I'm obviously going to drop this column because it doesn't look to me like there's any. It doesn't look to me like there's any way to salvage this guy. 0, 0, right? So it doesn't look to me like this guy is going to give us any special insights, since it's a very, very, very badly distributed. Whereas previous is a very, very bad. So almost all the variables in this previous are 25. Let me go back and look at it. Where's previous? Okay, sorry. Right. So almost all the values here are 25. So I probably have no idea what to do with this guy right now, but to drop him. Right. So this is very, very badly distributed. Where are you? So I've seen that, where is it? I've seen that this guy is badly distributed. And I've looked for ways to help him, but I cannot help him. But even from the graph, you can see that this is badly distributed, right? So it's either you leave the guys here or you drop the rest of these guys here. Unlike P days that still looks okay, campaign still looks okay. Campaign doesn't even look too far from previous. So let's go to campaign.
But if you leave previous day, is it going to affect your insight?
I don't know. So I'll have to check. I'll have to run the whole process to see if it's going to affect my insight or not. So I'm not going to, that's the reason why I didn't drop it yet. But I know that I have a problem with it. And I've written it down in my notes. That these three guys, though, then get problem. Right? And then I've come to my df.describe, my statistical analysis. Right? And I've seen where the problem is. Right? I know that none of these rules have met all of these criteria. So before you go into machine learning, you have to come and make sure that all of these criteria are met. This is particularly for machine learning, not necessarily for EDA. It's good for EDA, but it's particularly for machine learning because all these conditions must be met for machine learning to fit to your data. But it's also good for EDA, that's why I included it. Right. So I said I wanted to rush through. So let's analyze the response column. So we've analyzed categorical variables. We've analyzed the input variables. So let's go analyze the response column, that is deposits, with a subplot or with a bar plot rather. And you can see that this doesn't look bad. We have more people declining a deposit than we have more people saying yes to a deposit, right? It doesn't look bad. So the next thing that we are going to do is, don't forget, there's one thing that we didn't do. Let's analyze how the deposit column value varies depending on other categorical values. Remember, I told you here that we need to do three things in EDA, right? We want to analyze the output variable. That's number one. Number two, we want to analyze the input variable and how it is related to the output variable. That's number two. We did these two things in this analysis. What I forgot to do in this analysis is to analyze how the input variable affects other input variables. Right, so you said that we still have work to do. So let's go. Let's see how deposit column value affects the rest of the guys. So this is how. What happened now? Okay, I need to run it. So there's something you can do. Just click on run all. If you run the code from the beginning to the end. What happened again? Okay, it means that the problem is in this code. The problem is in this code. The keyword deposit. Key error deposit. It's deposit now. No, the deposit be the name.
Is it possible that deposit might be a Python command or something?
No, it's not a Python command. I think it's a syntax error. Oh, okay. See the problem now. The new code I went to go and download, they changed deposit to Y. Can you see the problem? The new code, they've changed deposit to Y. That's why it ran error. It was a syntax, it was a variable error. I don't know where I saw that code self. Where I saw the data. So let's change this to y and run it. So it works. This is a different data. What's happening? This is a different data. Oh, this is a very, very different data from the one that I. What's wrong? How many times did I download this data? The one I downloaded is different. Where is it? Bank. Okay, hold on. Something is wrong. Control H. I'm not for download. The one I downloaded is different from this one. I don't know why. Okay, I downloaded this from Cable. This is one I downloaded from Cable. From a folder. This is it. Let me go back to. Sorry. Let me go back here. Let me rename it. Okay. All right, so let me go and load it now. So it seems like the banking data set I downloaded from Kegu and the one you downloaded from UCI are different. It looks to me like because this one has Y. Okay. Oh, good. I need to go and download your data sets. Okay, let me go on with this. Let me go on with this. Let me go on with it. Are you guys there? Hello? All right, great. Okay, let me just rush through. So what we want to look at right now is so this is the distribution. So we have more guys saying no to deposit than yes. And we want to find out who are these guys that are saying no. And now we can target the guys that are saying yes. So I mean, this is context. You could want to say, for example, let's convince these guys that are saying no. Let's look for the guys that are saying they don't want to deposit and find a way to convince them, right? That could be the motive of the bank. Again, another client will say, you know what, let's leave these guys that are saying no, we don't have much strength. Help us look for these guys that are saying yes, let's approach these guys. So data analysis and data science depends on context, depends on the business use case, right? So I'll need to change all of this from deposit to Y. I don't know. Okay, let me do that instead of doing name change. Instead of doing name change, let me just change this now. So let's see, how does job affect deposits, right? So this is a bar plot to show you how job affects deposits. What insight can you get from this?
I'm sorry, please come again. I didn't get the whole thing before we got here.
We analyzed the deposit variable, the response column now, and I said that there are more guys saying no to deposits than guys that are saying yes. Don't forget, this data set is data set of previous campaigns by this bank. They've sent out campaign messages to 11 to 4,000 customers in this data set. And majority of the people here said no. Just close to 4,000 customers said no. Just close to 500 customers said yes. I now said that EDA or machine learning depends on context. This bank, for example, might decide that they want to convince these guys that said no. They want to reach out to them and find out why they are saying no. That means that the purpose for this data analysis is that help us find out why these customers are saying no. Some other clients can say, you know what, we don't really have a large marketing budget. So help us find these guys that are saying yes. Let's quickly reach out to these guys. Help us find the features that are peculiar to these guys that are saying yes, so that we can just reach out to the new customers that are showing this characteristic. Does that make sense?
Oh, okay.
What I'm just trying to let you see is that this thing, there's no one size fits all to data analysis or data science. It just depends on context and business logic. Right? So that's analysis for response column. Now we want to see how our input variable, how we affect the output variable. So in this code, we compared job, right? So this job now, we want to see how these guys, blue collar entrepreneur, housemaid, blah, 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 how does it affect deposits? Now, this is the bar plot. What insights can you gain from these bar plots?
So most people that are in management that have blue collar job, they deposit more. Okay, no, sorry, no, they do not deposit so much because sorry, no.
Essay.
Sorry.
Okay, go on.
So at least let's compare those that yes. So we have more people because we have more. I think because we have more people in management and then admin don't. But we still have, so like the highest people can also add retired, because retired and admin are more or less like on the same par in the but definitely.
Okay. Okay, is that all?
Then those who are unemployed, the deposit less.
So can you see that my hypothesis is correct? Right? So I said management guys. I was not too correct on retired guys. What's this BC? Blue collar guys. They were obviously going to be the ones that would have the most amount of money. Right? So from here, I could write a report. EMC meeting, executive management meeting, Monday morning to GTB, that from now, track management, technicians, and blue collar workers. Forget these guys. Because these banks, they have millions and millions in their marketing budgets, and they don't want to waste their time, right? So they don't want to waste their time targeting someone that is unemployed, targeting someone that is housemaid or an entrepreneur or a student. Now it's easy because this particular feature is very easy to figure out. That's why it was easy. But sometimes some other features are not easy to figure out, that you have to see them from visualization and just write, see, target these guys, target these guys, target these guys, and then you get paid. I mean, this is just insights. So now let's start to put together. I don't have time to explain, but okay, let's see. Let's start to put together our insights now. Let's start to put together our insights.
Or can we continue the class so that we don't worry?
I don't think I have that time, but let's see where we can end. If I can create time tomorrow, I'll create. I don't know. I can't promise, but I'll create time. But I would want to make sure that you do your statistics class this week. So so what are we telling EMC meeting Monday morning? Note to, there's a department in the bank you call, what do you call that department again? Okay, let's just call it digital marketing department. But there's a name they call it.
Marketing and communication.
Customer something. Customer something. Okay, let's just call it digital marketing, right? So targets, who are we targeting now? Target management technician and blue collar. Okay, let's add admin and retired, just in case. So target management, blue collar, technician, admin and retired. So these are the guys that obviously get paid, right? You could figure this out without even looking at the data, right? So this is number one. So let's go to marital status. Let's say our marital status affects. The last data set that I used was more balanced than this. I don't know how I mixed it up. Yeah, no. Okay, so what do we gain from marital status?
Marital status, you married and you're single and live in divorce. But majorly married people, more married people are most likely to put their money in fixed deposit.
I don't think so. We had more married people saying no than single people.
But more married people are also saying yes. Exactly. Thank you, that more married people are also saying yes than single people.
So there's no one size fits all to data insights. But I would rather take a closer look at the amount of married people and the amount of single people in these data sets, right? It looks to me like these single guys are more open to taking risk. I mean, just from basic knowledge about things that are real lifestyle stuff. Single people, I'm a single guy. I've taken more risk. I've lost more than 3 million in the last 2 years. And I lost that money because I'm not married. Once I get married, you cannot be taking any kind of mumu risk again. Single people are more risk averse. So single people usually want to be susceptible to your deposit campaign than married people. Does that make sense? Does that make sense? So sometimes it's not just what the data is telling you. Sometimes you need to add context to your insights. Single people are more risk averse, right? Look at the blue bar. This is not far from this now, but look at no. No is too far from this. Is there any consenting opinion? Has the class ended? Is there any consenting opinion?
No, since you said that
I don't want to lord my opinion over your own because it's based on context, right? Like you guys have brought and that's why I wanted you to be interactive. I'm not teaching. I'm teaching. Well, maybe I'm teaching, but then it's just context and understanding that matters in data science and data analysis. You could be seeing something else that I'm not seeing. That's why companies employ more than one. They employ as many as 10 data scientists because someone could be seeing. So 10 of us could look at the same data set like this, and the 10 of us would be seeing 10 different things from the same data set. Okay, so let's distill. Single people are more risk averse than married people.
Okay, so I want to say something.
Go on.
Another reason why we are not having that for single people that for married people, could it be that the data number of single people we have on the data is not equal to the number of married people?
Exactly. Yes, you are correct. That's why I was not happy because the last data set I worked with, the no and yes was almost the same thing. I don't know how I mixed up the data sets. Right? No and yes were not too far from each other, and that would have been a good way for you to visualize it. But now that we have these data sets, we will still need to work with it. Let's imagine that the other data set did not exist, and this is what exists. You still need to work with this, right? So that's why I just went on with it.
So that means it is like in a ratio of 2:1, right?
I don't understand.
So that means like the data that we have for marriage, like 2, then for single ratio, like 2:1.
It looks more like it's more than 2:1 self. So let's go to education. Let's see how education affects. Oh, this was the previous data set that we had. Okay, no, this is the new one. So what do you see from education?
People with secondary school education.
Wait to. How many roles are in education? There are more now. There's high school, there's illiterate, there's professional course. What's happening? There's university degree. What is happening? There should be more than this. So let me go and look at education. What's happening? Where is education? Let me see. Let me do df.info. Something is wrong with this data set. I feel like we got the wrong data set. Df, because it should be like 11,000. I don't know why it's 4,000. df.info. Something is wrong. I think it's just from the data sets. I think it's just from the data sets. Education, we had just 4 here, and we should have had more than 4, right? But okay, let's just imagine that it's just 4. I think it's data sets. I mixed it up. Let's just go on. So let's just imagine that we had 4. Because obviously, from my hypothesis, I predicted. What did I predict? I predicted professional guys and guys with university degrees will have more money, right? But let's just manage this. I'll find that data set again and send it to the group. So we don't marital status. So education now. Now again, this is where context comes in. Okay, let's just imagine that this was the real data set and we had more no's than yes. She. We have more people saying in this bracket they are depositing. Obviously, tertiary, secondary bigger than tertiary, bigger than primary, bigger than unknown, right? But at the end of the day, we had more people in this same secondary saying no than in tertiary saying no than in primary saying no. So this is like a straight line graph, right? It was a straight line graph, while this is also like a very straight line graph. So what can we bring out from this relationship? I want you to look at it. What can you bring out from it?
It could also be that more people in secondary field perform than the people in tertiary. So I would still say that we can target people in tertiary and just direct a little bit of marketing effort to people in secondary.
I mean, because at the end of the day, if you look at the distance between yes for secondary and tertiary, is not too far. But the distance between the no is very far. Right? So again, instead of going with secondary because they have the most yeses, I think I would go with tertiary. What do you think, Layo?
Yes,
All right, so let's go. So I'll need you guys to document while you are running the code. I want you to document your insights. The way I'm documenting it here, I want you to document your insights inside your collab notebook. So all you just do is once you run the code, click enter and click on hash, and then you can write anything. So document your code inside your collab notebook and then send it to the group. So here now we have prioritize tertiary than the rest. Depending on their marketing budget, they could prioritize tertiary and secondary, but for this, we want to prioritize tertiary, right? So that's our insights for here. Also, let's look at the deposits. I don't have this much time, but let's see if we can rush it. Let's look at contacts. So it looks like the guys that we contacted via landlines deposited more than the guys we contacted via telephone. What do you guys think? What do you guys think?
Well, I actually think that in present day context, most people use more telephone than landline. And the people that send for telephone is actually smaller compared to the people that send for landline. So I think like a direct marketing effort to telephone and maybe a bit landline. I don't know.
How about you? Like, what do you think? Look at it. Just look at it again. I mean, this could, the way I look at it again, it could be that they sent more messages via landline than telephone. It could be. And it could be that they sent messages generally via all of the platforms, right? But for this project, let's just imagine that the bank said that they sent messages generally, but more people responded via landline than telephone. So what does this tell us about this relationship? Is that there? Hello? Okay, this class is going to end very soon. So let's go with essay. So you know what I want you guys to do? Are you guys there? So I want you to run the rest of the code. And I want you to run the rest of the code. I want you to comment on the insights that you've gained from this data set. Comment it on your in your collab notebook and send it to the group. Is that okay? Does that work? Right. So you can send it to the group. Yes, it's in the group already. I'll send it again. That's it. So I want you to run the code and put together the insights that you gain from